A wheel and axle of radar 800 mm and 200 mm respectively is used to raise a body of weight 800 Newton by the application of 250 Newton. Calculate the efficiency of the machine. The option A is 85%, option B we have 80%, option C we have 60%, or option D we have 20%. So the question reads that the rates as follows: a wheel and axle of radii 800 mm and 200 mm respectively is used to raise a body of weight 800 Newton by the application of 250 Newton. Calculate the efficiency. You have to calculate the efficiency of the machine. We know that from this diagram, this is our wheel. This is our wheel. This is our wheel, and this is our axle. We were told that the radius of the wheel is 800 mm, while the radius of the axle is 200 mm. That is our small r, while this is our capital R. And we know that our velocity ratio is equals to the distance moved by the effort over the distance moved by load. So this is the distance. This is where we are going to apply the force. This is where the force input is. This is where the force is applied. This is where the effort is. So the distance is the distance moved across this ring, which is a circle. So, and by that we have the distance moved, the total distance across a circle. That is circumference of the circle, and we have that as 2 pi, the radius of that circle, which is 800 mm in this case. So times 800 mm. Then we have divided by the distance moved by the load. This is the axle carries the load. This is where the load is being carried. So it is the axle that carries the load. So the distance moved by and is also a circle. It's also in form of a circle. So the distance moved by the load will be 2 pi times the radius of this axle, which is 200 mm. So mm will cancel out mm, 2 pi will cancel out 2 pi, and 200 here, 200 here, we have 4. So our VR is equals to 4. That's the first step. The second step, we know that our MA, mechanical advantage, is given as load over effort. And from the question, we were told that we are told that the machine is used to raise a body of 800. That is the load that is being carried. It is used to this is where you apply the force. This is where you use this one to raise the body, to raise another body. So it is used to raise a weight of 800. So the load is equals to 800 Newton divided by the effort, by the application of 250 Newton. So the effort applied into the machine is 250 Newton. So Newton cancel out Newton, and here we have our MA to be equals to this one. This is going to give us 0 cancel out 0. This is going to give us 3. That's 75. Then we have 5. So this is going to give us 3.2. So our MA is going to be equals to 3.2. That means our efficiency is equals to MA over VR. So we have our MA to be equals to 3.2 divided by our VR, which is equals to 4. This is going to give us 3.2 divided by 4. That is about 0.8. So our efficiency is equals to 0.8, and we can convert that to percentage. That is 0.8 times 100 over 100, that is in percentage, and this is going to give us 80%, that is 80 over 100. 0.8 times 100 will give us 80, then divide by 100, that is the percentage. So our efficiency is equals to 80%.